Okay, so now we are discussing pipes in series topic. So let us solve a problem on that, how we use the methods that we just discussed to solve the problems. Now this is problem 8.9.1 from the textbook. Suppose we have in the figure three pipes are now connected. We have one pipe, this is second pipe, and then we have the third pipe. So the data is given, and it is stated that the total head loss, that is 6 meter between A and B. So it means that this head loss is given. This is given 6 meter. This is now given to us. And for the three pipes, the lengths are given, the diameters are given, and in this case, the friction factors are given. Clear? So now first, as we studied that we have two cases that we have studied. Now in this case, the total head loss is given, and we have to calculate the discharge. What we have to find out? We have to find out the discharge. So first you have to identify that this is which case. Clear? So this is case 2. If you remember, this is case 2, for which we have to calculate the discharge, and the total head loss is given. So now in that case we have two methods. Either you apply the equivalent velocity head method in order to calculate the discharge, or we can also apply the equivalent length method. Clear? So first let us see, we apply the equivalent velocity head method. In that case, we already discussed that the equation is given by this form. So now essentially in this case what we have done is that we have expressed the velocities of second pipe and third pipe in terms of V1. You can see here in terms of V1 we have expressed the other velocities. That's why it is known as equivalent velocity head. So now in this formula you can see that F is given, L is given, D is given, and so on. So just you need to put the values, and in this case this HL, this is also given. Clear? 6 meter. This 6 meter which is given, that you put here HL. So in this case the only unknown is this V1. This V1 is unknown. So now we calculate, you plug in the values, and then we calculate that this V1 is equal to 0.63 meter per second. And then we already know that Q1 is equal to A1 into V1. So you plug in the values. So the discharge comes out to be 0.00317 cubic meter per second. So you can see that we can easily solve the problem. Clear? Now in this case, remember that we express V2, if you remember V2 and V3, that we express in terms of what? In terms of V1. So that is why in the whole equation, and that V1 is here. So that's why in the end what we get? We get V1. That is why we are able to calculate V1. And then we can easily calculate Q1, which is the discharge through this pipe here, 1. So now we already know in this case that in this case Q1, that will be equal to Q2 equal to Q3. Clear? So once you calculate Q1, it is equal to Q2 equal to Q3. But if you proceed with V2, then it will be V2 here. You can calculate Q2, or you can express clear V2 and V1 in terms of V3. Then here you will calculate V3. This will be V3 and you can calculate Q3. Meaning to say is that it's not always that you will calculate V1 and then Q1 and so on. It can be V2, it can be V3 and so on if we have more pipes that are connected in series. So as a check, what you can do is that now V1 we have calculated, so you calculate V2. We can calculate easily now. You can just plug in the values and V2 is this much. Now from Q2 is equal to A2 into V2, you calculate and the discharge is 0.00317. You can compare this here, 0.00317, get the same result. Similarly, you can go for V3 and calculate Q3. You will get the same result. Clear? Now, next we apply the equivalent length method. Let's see that we get this result of 3.17 liters per second or not. Because we discussed that there are two methods that we can apply to solve this problem when the pipes are connected in series. For case 2, the head loss is given and we are required to calculate the discharge. So as I said that this much the problem is sufficient, we already get the discharge, but we apply this second method to calculate that if we get this discharge or not. And as I said that in the 8th edition, for example, of the book, older editions of our textbook, you will find that they discuss the equivalent velocity head method and the equivalent method both. But now in the 10th edition, they do not discuss this method. Only just they discuss the equivalent velocity head method. But anyhow, we will apply both in order to see that we get the same result or not. Clear? And this is also for learning purpose. So in the equivalent method, what we do is that we have to select one of the pipes, either pipe 1 or pipe 2 or pipe 3, any one for the given pipes connected in series. That can be selected as the effective pipe. Clear? And what we will do is that we will calculate the effective lengths for all the pipes in terms of that selected pipe as effective pipe. So let us proceed how we do it. We already discussed and derived this equation that we can calculate the effective length for any other pipe, clear, which will have the same head loss for the same discharge. So now in this case, you plug in the values. Everything is known in this case, clear, because we select pipe 1 as effective pipe. So this effective pipe will take all the properties of pipe 1. So that's why when you put the values, then the effective length of pipe 1 will be 150 meter. What is the length of pipe 1? If I go back to the table, what is the length of pipe 1? It is 150 meter. Because we select pipe 1 to be effective pipe, what should be its length? That will cause the same discharge Q1 for the same head loss HL1. So its length comes out to be what? Its length comes out to be 150 meter. Because pipe 1 is selected as effective pipe, its length remains the same as 150 meter. This is the concept of effective pipe. So pipe 1 is now effective pipe, so its length remains the same as 150 meter. Clear? Next we calculate the effective length for pipe 2. Now in that case you plug in the values. because we know all the values for pipe 2 and effective pipe, and effective pipe will get all the values from pipe 1, because this we declare pipe 1 as effective pipe. So it means that FE will be equal to F1, DE will be equal to D1, and L1 will be equal to LE. This is what essentially we are doing here. Clear? So now when you plug in the values, then in that case, this LE2 effective length, that comes out to be 703.16 meter. This should be the length of the pipe. In order to cause the same head loss as that of the pipe 2. If you compare here, we go back to the table and you look here, now the effective length of pipe 2 is no longer 60 meter, because now effective length of pipe 1 is 150 meter. So if you want to replace pipe 2 by effective pipe, which is now selected as pipe 1, then its length should be not 60 meter. Its length should be how much? Its length should be 703.16 meter. Clear? Then it will be the equivalent length. This is how the equivalent length concept comes. It is not equal but the equivalent length. If pipe 1, if we want to replace C703.16, if we want to replace what? This pipe 2 here, you want to replace this pipe 2 with effective pipe length, that will cause the same head loss as the pipe 2, and the pipe effective pipe we select as pipe 1. What should be the length? What should be the length here of the effective pipe that will cause the same head loss as this pipe 2? So that should not be 60 meter, it should be this much here, 703.16 meter. Next we calculate LE3. So for LE3 you plug in the values for the effective pipe and the LE, the pipe 3. So you will get the length is 535.42 meter. So now what will be the total length of the effective pipe? That will be sum of the three values. Now what we have to do is